Okay. So yeah, this is your formula, difference of squares formula. I've drawn a picture here to show you why the formula is like it. But if you expand your a minus b times a plus b, we'll see what we get. You'll get a times a squared, minus b times a, minus ab, and then a times b, ab, and then b minus b times b, which is minus b squared. The middle two terms will cancel, and you'll get a squared minus b squared. Okay, so we know this is going to be correct just by doing some algebra, but we can actually use a picture to think about why the formula is like this as well. So what we have here is a square, length A in both directions. I want to show that a squared minus b squared equals this here. So a squared is the area of this large square, right? The big square. So area of large square. Okay, that's a squared. A squared minus b squared. B squared is down here, this area here. So I'm taking my big square and taking away the green square, the small one. So when I do that, you see the green square is gone here. And what I've done is I've rearranged the boxes. So if we look at this length first, before we go too far, this is length B here. Okay, this is all B. The length of the yellow is A minus B. So if this was 10 and this was 4, this would be 10 minus 4, which is 6. So that makes sense. So this is A minus B, which means that this length here is also A minus B. I'll put that here. And the length of the blue one is B. So that's here. And the length of the pink one, or purple, pink, is also B here. So if we think about the area of this square, we've got A minus B, and then this length is A minus B plus B plus B. The middle two B's will cancel. So the length of this line is A plus B. So think about the area of the total shape. So that's A minus B times the length, which is A plus B, which is your formula here. Okay, so when you've got A squared, so this is A squared minus B squared, take away your green square, we'll have this shape. And I rearranged it. I put the blue here and I put the purple. These colors can be swapped. It doesn't matter which one you put first. So the area is equal to A squared, A minus B times A plus B. So A squared minus B squared is equal to that. So you can prove these using diagrams, okay? And A and B are any number you like, any real numbers. All right, so we'll see how to factorize using the examples here. It's a bit small. Let me make it a bit bigger. All right. So your first question, we want to factorize this expression. What you need to be looking for is a minus sign here. This needs to be minus. There. Everyone will have minus. If it's x squared plus 36, we can't do this with this formula, and not with real numbers. Not with real number. We can do it, but not in grade 9. Okay, we don't need to worry about doing this now. Okay, so you've got x squared minus 36. The first thing to do is make sure everything is power 2. Because if you look at your formula, I'll write again, a squared minus b squared, you need to have everything as a power. A minus b, a plus b. We'll keep that there so we can refer to it. So x squared is no problem, x squared. The 36 needs to be changed to 6 squared. So what we'll do, we'll write that first. So when you do this work for me in your homework, you'll have x. So we'll have x squared minus 6 squared. Okay, so that's the first line that you should always write. This will help you get the right answer. If you skip, some of you may make errors, so you need to be careful about this. So then you've got x squared minus 6 squared. So we can use our formula now. So this would be x minus 6, x plus 6. So if we compare to the formula, we'll have a squared minus b squared is a minus b, a plus b there. So everything matches up like that. A, b is 6, a is x, b is 6. So in this example, we've got 36 and 121. So we need to change these numbers. I'll do it in blue. So 36 is 6 squared. So you'll have 6x all squared. So remember that rule, a squared, b squared, you can combine as ab all squared. So very useful rule here. So put that as a bracket. And then 121 is 11 squared, like that. So now we have a negative, which is good. And we have 2 perfect squares, 2 powers to 2, 2 powers of 2. So now we have 6x minus 11, 6x plus 11, like that. So just be careful, these numbers need to be changed. Okay, now this one, question 3, I won't go up too fast. You can copy it if you need to. So 3 minus 12x squared. The thing here is that we can factorize first. So do your distributive law from lesson 1. And we try to factorize because we've got a 3 here. And you're going to end up with a bit of a mess if you try to start square rooting these numbers. So the best thing to do is take a common factor out, which is 3. So then you'll be left with 1 minus 3 times 4x squared. Okay, so now this is good because 1 is the same as 1 squared. So then we can write 3, 1 squared minus 2x all squared, like that. Any problems so far? Okay, so 2 squared is 4, x squared is x squared. So these are the same. So when you have your difference of squares form, we can then expand or write your factors. So 1 minus 2x, 1 plus 2x, and that's finished. So you've got a constant 3 in the front here. That's okay. You don't need to multiply back in, just leave everything like that. That's finished. Now this one looks harder, but it's not. It's exactly the same. In this case, this is a, that expression 3x plus 4. B will be here, which will be 15 squared, isn't it? 15 squared is 225. And then, so what we'll do, we'll write that as 3x plus 4 squared minus 15 squared, like that. So now you see you've got a squared minus b squared. So that would be 3x plus 4 minus 15, and then 3x plus 4 plus 15. So almost finished, but now you have these numbers which can be simplified. So 3x minus 11, 4 minus 15, 3x plus 19. Okay, so that one's finished. If you want to expand, you'd have to expand, and then I don't think you could check this very easily. You'd have to expand this as well, okay, if you wanted to check it. In this question, we've got a number in the denominator, not a problem. Think about this rule. A on B, A squared on B squared is A on B all squared. Another useful rule that we can use, index law rule. So what we should do here is change your 16 and your 25 to be perfect squares. So you'll have y squared on 4 squared minus 5 squared. So using that rule here, we can make a bracket. So y on 4 all squared minus 5 squared. So now we just use our rule to write the factors. So y on 4 minus 5, y on 4 plus 5, and that's finished there. Okay, if you're copying, I'll go up fairly slowly. Okay, one more example. Now, when you see 4 terms, think about grouping first. So does grouping work? So we'll try that. We don't have 2 terms like we had in the previous one, but now we have 4. So try to group first and see what happens. So we have here p squared q minus p squared. The common factor will be p squared. So this is from lesson 2. And then we'll have q minus 1. Okay, just check that by expanding. Write down your sign here, minus. The common factor here is 16. And then we'll have q minus 1. So don't just copy the plus here, because you need to consider this minus sign. So minus 16 times minus 1 is 16, which is what you want. Okay, so don't just copy the plus because you have a minus outside the bracket here. So expand it and double check you're working. And remember, I told you these two factors should be the same. That's your common factor. So we'll write that as q minus 1. And then we have p squared minus 16 from the grouping method here. So you can see we're not finished because this is a difference of squares as well. Q minus 1 is finished. So we write that down. And then we have p squared minus 4 squared. And then we use our rule to write the factors for that. So that's q minus 1. P minus 4. Yeah, we'll just write it down, p plus 4. Like that. So in this question, you ended up with 3 factors here, 3 different factors. So if you have grouping method, that's quite possible. You're going to get more than 2 factors with the grouping method. Okay, so if you're copying that, I'll just move it up a little bit. Okay, but I'm recording all of this and I'll send you the file, but in my file, I may not have all the working that will be in the video. So if you're ready, I'll leave that for a minute. If you're ready, you can go to your exercises, which are down here. I'll just move that to there. I think you have time to do all of the problems. Okay, you can do all. And I will review some of the answers towards the end. It's 10:40, 10:38 now. So I'll give you about 15 or 20 minutes to work on them. Okay. So can I scroll up? Got that? You may need that for question U, that example I just showed. So what I want you to show, I'll do the first one, the kind of working you should show. So you've got x squared minus 16. So copy the question. Your next step is to make that as powers of 2. So x squared minus 4 squared, write that step next. And then once you have it in this form, then you can write your x minus 4, x plus 4. So when you're doing your homework, don't miss the middle step. I like to see what's happening. Because if you make a mistake, I need to see what your mistake was. Okay, so you should have 3 things written. Write the question, write the middle step to power 2, and then write the final step there. So we did A already. I think A, B, C, D. We can look at question D here. I'll send you all the answers anyway later. So for question D, we have 81x squared minus 4. Well, 81 is 9. And 9x all squared minus 2 squared. 2 squared is 4. 9x is 81x squared. And then just write your factors. So 9x minus 2, 9x plus 2. Okay, that's question D. One like question I. So I think ones that you may have problem with, I can do those. So x squared, y squared minus 100. You've got x squared, y squared. So that's xy all squared using the rule from earlier. And 100 is 10 squared. So then we've got xy minus 10. The neighbor's doing some work. xy plus 10, like that. Okay, that's question I. The same for J, the same for K. What about L? B, 2n minus 16. That's L. Minus 16. So we can change the B2n to put the n on the inside and put a 2 on the outside. Because that rule is AMN can be written as AMN, or you can swap the n and m around. Doesn't matter which one goes where. And you can have n on the inside and m on the outside. It's the same thing because they're multiplied. These numbers are multiplied to give mn. So I put the 2 on the outside because I want to have a square. And 16 is 4 squared. So then you're going to have bn minus 4. Don't worry about what n is, doesn't matter. bn plus 4. Those will be your factors there. Okay, so be aware of that. Question M. Let's do that one. We've got x plus 2 squared. It's already a power 2. Don't expand it. Don't need. We already have the correct form. A squared minus b squared here. So that would give you a minus b. So x plus 2 minus y. And then a plus b, x plus 2 plus y. Like that. And there's nothing else you can do there. These numbers are different. Okay, so you leave it like that. When you have a fraction like n, so x squared minus 1/9. So let's go down. Now for fractions, we can still change them to power 2 because 1 on 9 is the same as 1 squared on 3 squared, which is 1 on 3 squared, like that. So x squared minus 1/3 all squared from this here, all squared. So then we will just write your factors out. So x minus 1/3, x plus 1/3 here, like that. Okay. Some of the harder ones. Oh, Q. X squared minus 0.36. So you can still write 0.36 as 0.6 squared. So x squared minus 0.6 squared. Check with your calculator. 0.6 is 0.36. So just write out your factors. X minus 0.6, x plus 0.6, like that. So decimals can be done as well. If it was 0.37, then you have a bit of a problem. You end up with surds, but not today. What about t? 2x squared minus 0.08. I think in this case, I would factorize out the 2. So take out 2. You'll get x squared minus 0.04. So you'll end up with 2 x squared minus 0.2 squared. Like that. 0.2 times 0.2 is 0.04. You can check with your calculator. So then we're going to have 2 x minus 0.2 x plus 0.2, like that. Okay, not too hard, is it? You just need to be careful with decimals and fractions. A few more minutes. What about that last one, u? I'm going to clean the board here because I want to just do it here. Okay, we'll do it at the top. We have about 4 minutes left, so do a bit more. Okay, so we'll do this one here. So again, we have 4 terms. So it's telling you probably you need to look at the grouping method. So x cubed minus x squared y. X squared is a common factor. Take it out. Then you'll be left with x minus y. Bring your sign down, minus. 9 looks to be the common factor. And this will be x minus y. Check by expanding that this is correct. Minus 9x. Okay, minus 9 times minus y plus 9y. So they're okay. So now you see the common factor is x minus y. Take that out the front. And then you'll be left with x squared minus 9. So in the test, you'll get some marks for that, maybe 1 mark, but then you still have a bit more to do here because you can see you have a difference of squares here. So that would be x minus y. And we can just write that down as x minus 3, x plus 3. I'll skip the middle step. Like that there. So in question W, you already see this is in the form a squared minus b squared. Okay, so we'll just write that down. So you've got 5x plus 2y. But then you need to subtract this, 3x minus 7y. I'll keep that in a bracket. And when you're subtracting, you need to use a bracket here. And your other factor, 5x plus 2y. And then you add 3x minus 7. So I did that because you need to subtract the negative 7 too. So this is 5x plus 2y minus 3x minus negative 7 is plus 7y. Many students miss this point here, this part. So be careful about that. So then you've got 5x plus 3x, 8x, 2y minus 7y, isn't it? 7y, I forgot that. So 2y minus 7y is minus 5y. So in the first factor, you've got 5x minus 3x, so that's 2x. 7y plus 2y is 9y. and then 8x minus 5y. So that's the final answer there.